The Systems, Signals, DSP and FFT pack introduces students to a number of concepts in digital systems, including A to D and D to A conversion, Nyquist, digital signal processing, signal manipulation, Fourier analysis of signals and the FFT algorithm, and digital filters. Students perform a range of experiments that teach them about the details of signal manipulation using a single Sysblock, using pre-written programs created in flowcode. They also use a signal generator, an oscilloscope, and a signal analyzer to allow them to see the effects that DSP can have on signals. Students download the programs and carry out a number of experiments that teach them about the parameters and techniques of signal processing. There's also plenty of chance for creative programming using flowcode for more advanced students who will find that the Sysblocks and flowcode combination provide the perfect platform for the rapid creation of signal manipulation systems. So with the System Signals, DSP and FFT course, we've got quite a few learning objectives, which include analog to digital conversion, digital to analog conversion, Nyquist, digital signal processing, signal manipulation, convolution and level detection, Fourier analysis, FFT systems and digital filters. And of course there are lots of other things you can do with that as well. We've given you some curriculum which will start you along the DSP and FFT route, but you can add lots of tasks and make your own programs to expand that work if you want to. So what I'm going to do now is just going to load a different program which is taken from the course. This particular program looks at how square waves are made from the harmonics of a fundamental, and it allows you to add different harmonics into the channel and see the effects. And here, rather than using a audio input and output and listening to the results, we're going to use a picoscope to look at the signals that are produced. Okay, so you can see this is the flowcode program. We've got the data flow program here, and you can see that we've got an adder, we've got lots and lots of oscillators, and then we've got some amplifiers, and the signals then are fed into the mixer and then fed to an output. And at the same time, we've got just another signal which we're using as a reference. So you can see the fundamental sine wave, and then you can see the resulting signal that is generated by adding lots of odd harmonics from the fundamental. You can also see this is the Sysblocks control component, which allows students to easily access the functionality of the encoders and the switches and the LEDs. The program itself is a bit more complicated than our first one. Most of it governs how the encoders and the switches work rather than the actual DSP program. So there's a main program, there's a timer interrupt which activates a macro called generate. Inside generate, all you've got is the macros for each of the individual DSP icons on your data flow program, and then you've got another macro called set depth, and what this is doing is it's managing the encoders and switches. But this program is supplied for students. They can of course alter it if they wish, but here what we're doing is we're getting students to download that to the Sysblock and then use the picoscope to see the effects. So looking at the oscilloscope output, the left-hand encoder is being used to add different harmonics. And so here you can see the fundamental frequency where only one signal is being used. And then this is the same output signal where we've added a third harmonic, and then a fifth harmonic, a seventh harmonic, a ninth harmonic, an 11th harmonic. And you can see now the sine wave has changed to something which is getting closer and closer to a square wave. So this program just allows students to confirm that square waves are made up of sine waves with the different harmonics. So that's one program, and we use lots of different programs in that Signals, Systems, FFT and DSP course to help students understand the entire subject.